thinks alien engineers might approach the challenge of traversing the galaxy the same way we do.
As a physicist, I have to make assumptions about the way the universe works. The way it works in my lab has to be about the same way it works in the lab across the street, across town, somewhere else on the planet, or somewhere else on the other side of the galaxy. And when you start thinking about that and what it's going to require to travel between the stars, you have to think big. You have to think bigger than the Saturn V rocket, which took people to the moon.
The liquid propellant-fueled Saturn V is still the most powerful rocket ever built. It allowed astronauts to travel 618,000 kilometers to the moon in just 4 days. But for aliens to get to Earth, from even Proxima Centauri, our neighboring star system, means a journey of 25 trillion miles.
To get this enormous beast off the ground, these engines had to produce millions of pounds of thrust using chemical propulsion. If we were going to try to go to the stars, and the distances are just huge, right now with a chemical rocket like this, it would take 73,000 years.
Faced with thousands of years in the cockpit, Johnson thinks extraterrestrials might consider using a more explosive fuel system.
Now, instead of the Saturn V, imagine a battleship, something really big, with big pressure plates underneath it, and instead of chemical rockets, you explode small hydrogen bombs. One every few seconds. And as the bomb explodes, it gives it a kick, and it starts it moving, and it keeps it going faster and faster. And if you accelerate for hours instead of the minutes that a chemical rocket does, you could potentially propel a spacecraft to another star in a few centuries instead of 73,000 years.
Hydrogen bomb-powered spacecraft would be fast, but dangerous. So Johnson thinks advanced aliens could develop something much faster and safer, using alternative energy.
My personal favorite technology is called a solar sail. What a solar sail does is it reflects the light to get propulsion. You can't really feel it here on the ground, but the sunlight, as the light reflects from you, are pushing on you. They exert a force. If you get out into deep space, this force can be significant, and it's plentiful. It's always there. With this prototype solar sail, which is actually one that we developed for solar sail applications, is a very thin, lightweight reflector. Now imagine something like this, only scaled up dramatically. Something the size of Texas, with the thickness of a human hair. If that were to be deployed in space by us or someone else, they could use that to get a big kick from sunlight to travel very, very fast. Now, this technology doesn't require many fundamental breakthroughs in physics. It's more of an engineering challenge. We don't know how to build something like this the size of Texas today, but we could probably, within a few years, build one that's a few kilometers in size, and within the next 50 to 100 years, scale that up to the sizes you might need, or anyone might need, to travel between the stars.
Even using solar sails, traveling the 4 light years to Earth could take a century or more. For a really express journey of just a few decades, aliens need to harness the incredible power of a mysterious substance called antimatter.
Now, antimatter is really the ultimate fuel for interstellar travel. And just to be clear, it's not the stuff of science fiction. It's very real.
Antimatter consists of subatomic scale particles that are a mirror image of the ordinary particles that make up all matter in the universe.
The reason it's a good fuel is because when a particle of matter and antimatter come into contact, they annihilate and produce energy. Now, to give you an idea of how much energy that is, take a look at the shuttle behind me. That external orange tank contains all the fuel necessary to get the shuttle to orbit. It it would take 50 of those tanks to produce the same amount of energy as 3 grams of antimatter.
Just a tiny amount of antimatter could help alien explorers cruise across the galaxy at up to 67 million miles per hour, reaching Earth in a relatively speedy 42 years. And unlike the flying saucers of science fiction, an alien spacecraft could survive such unimaginable speeds no matter what it looked like.
When we think about spaceships, we usually think about the shape of a rocket, tall and thin and very aerodynamic. And that's really because we live on a planet and we've got an atmosphere above us. Well, once you get out of that atmosphere, you don't have to worry about that anymore. You don't have drag. So you can have a spacecraft that has lots of things sticking out on it, or not. It could be a cube, like a Borg cube. Basically, once you're in space and in vacuum, the shape just doesn't matter anymore.